For this video will be a pretty extensive dive into ggplot2. When you get into your visualization course next semester, I'm assuming you will spend a great deal more time with this program and this package than I'm doing right now, but I figured the best way to really learn this program or this package is to really dive into it via example. So most of this video will again take place in the RStudio environment, and we're going to just kind of be playing around in the sandbox, getting used to how it works. As stated before, the ggplot2 is a package that you must install into your system. Now the good news is, in the previous week we installed the tidyverse, and ggplot2 is a component of the tidyverse. So if you've installed tidyverse, you've installed ggplot2. However, you do need to use the library function to load it. And it is a little bit annoying to load it every session, but trust me, is worth it. Once again, if you load the tidyverse, you by default have loaded ggplot2, so you don't need to load both. ggplot2 is a package for more advanced or perhaps just better looking graphics. Many people just use this exclusively, so I would really treat the base R plotting that we've discussed so far as just preliminary quick and dirty plots. The ggplot2 is more presentation level, but even to a deeper extent, when you get familiar with it, it's actually also very useful for explanatory plots as well. It's much more easy to customize, but it does take a little bit more work to get started, which is why we're going to be doing this together in an example video. For this example, in this set of videos, we're going to use the MT Cars dataset, the Iris dataset, and the Diamonds data. I don't know if we're going to use all three, but we'll potentially use all of them. And they're already loaded into R. You don't have to do any special loading. To start, we're going to set up a simple scatter plot of miles per gallon versus weight. We got to set up the space, defining the data and aesthetics first. Now I'm going to go ahead and leave this slide here, and we're going to go into the RStudio framework. Okay, so as we said, we are going to follow the grammar of graphics, which means we start with the data level, aesthetics, geometry, and then some of the optional extras in terms of faceting, themes, coordinates, and statistics. Start with the data. So we're going to make a simple scatter plot of miles per gallon versus weight. We did that in the base R plotting. To do that, we're going to start by setting it up, saying ggplot we got to tell it what the data is. Well, the data, we're going to use the MT Cars data set. And then I have to go to the next layer of the aesthetics. To add the aesthetics layer, we use the AES command. There is no equal sign here. We are just saying, well, what are the aesthetics? Well, this is a two-dimensional plot. So I'm going to say in the X coordinate, I'm going to use weight. And on the Y, I'm going to include the miles per gallon. One thing to remember, I do not need to include $ notation. I have already told this function what the data set is. The data set is MT Cars. Therefore, when I type WT, it understands that this is a variable in this data set. Now, we can go ahead and say, all right, sounds good. We got the data, we got the aesthetics. Let's go ahead and run it. So I'm going to go ahead and run it and see what happens. And when I run it, I look over here and nothing really shows up. You might say, well, what happened? Didn't I do all the work? Well, remember, there are three components that are required. We have the data component, the aesthetics component, and the geom. And the geoms, the geometries, are what we see. So all we've told the computer is, well, this is where the weight's going to go on the x-axis. This is where the miles per gallon is going to go on the y-axis. But I haven't told you what to put on the actual graph. So to do that, I need to literally add a geom layer. So how do I add it? Well, I'm going to go to my ggplot function, and I'm going to add geom_point to put points on my plot. I want the geometry that I'm going to use is points. Now don't forget that I have parentheses after the geom point, because there are options I can specify there. I'm not going to right now, but I can if I so choose. Let's go ahead and run it. And there we go. I now have a graph. And you might say, oh, well, that's nice, but Doesn't really look much better than, or much different, really at all, than the base R. So why did I bother? And you're right, it really didn't change a whole heck of a lot. Maybe we want to say, let's add some color to this. And before I do this, I'm going to make sure that we are aware that I'm going to do this with the MT-Cars dataset before I've changed the factor or the cylinder to a factor variable. So right now, we'll examine the structure and we'll see that the cylinder is a numeric variable. So as we said here, the MT-Cars will examine the structure of MT-Cars and note that indeed cylinder is numeric. So let's go ahead and see what happens if I'd like to put some color on here. I'd like to say, can we make some aesthetic choices? I would like to see a red dots. Well, I could say, you know what, I'll just make them red, but that's just what we call an attribute. It's a color that everything gets the same. An aesthetic mapping is really saying I'm going to map another variable to the color aesthetic. To do that, I simply add in the aesthetic layer color equals, well, let's say cylinder. Let's see what happens. When I run it, okay, I got some different colors here, but boy, it's really tough to tell. I see some black dots here, I see some light blue, and then there's kind of a middle color in here, but it's not easy to tell. And the reason is that the computer looks at that and says 4, 6, and 8, those numbers are pretty close to each other. So we're going to keep colors that are fairly close to each other as we go through this. I would really like to distinguish these 4, 6, and 8 as very different variables. So how do I have them as very different groups? Is I convert it to a factor. So let's go ahead and actually run this exact same command, except instead of color being cylinder, I'm going to make it based on the factor of cylinder. And when we do that, you're going to see what we mean by aesthetic mapping. If you look onto the color scheme here, you start to easily see where the 4-cylinder cars are, the 6, and the 8. Notice the aesthetic mapping is actually putting cylinder onto the color scale. Now there are plenty of other aesthetics that you may use. You may like the fill aesthetic, the size, the color, the alpha, the transparency, the shape. And you might want to map different things to it. For example, let's go ahead and map a few of these other things. You know what? Just to make things a little bit more visible, I'm going to add what's called an attribute. I'm going to take the points and say these points are too small for me. So I'm going to say I'd like the size to be 3. Let's just kind of see what that does. It just makes them a little bit bigger. Now notice that I put the size attribute in the geom, not in the aesthetic. I could have put it in the aesthetic, but the point is this goes to everything. The aesthetic really should be mapping to different variables. So now I might say, all right, now that I can see it, I'm going to just copy this and say, yeah, let's keep the color as the factor cylinder. And let's go ahead and also add a shape. And the shape I want is factor, let's try automatic manual. I think I have the right number of, I think I have one too many. Let's double check here. One thing that I do like about R is that if I move in here, it shows me what parentheses that one's closing. Now you can see this one's closing aesthetics. This one's closing ggplot, so I'm good. Why did I do factor AM? Well, let's see what happens when I run this. Well, now you notice the colors are still the same. And it says, hey, for 0, which are automatic, we have circles. For 1, which was manual, I have triangles. I see most of the 4-cylinder cars or the lower weight cars are manual, as we'd expect, and most of the heavier ones are automatic. There's a couple exceptions, but again, I'm mapping something to an aesthetic. I can do it with size. I can say I'd like to see the example I have here in the notes suggests I'd like to have a plot of Q-sec versus weight, color-coded by AM, with the size of the point determined by the cylinder. All right, so let's go ahead and try that. ggplot. I'm using data's empty cars. You notice the arguments in R are positionally matched, which means the first argument is assumed to be data in this case, unless you specify it. AES, I would like to be, let's see, I wanted the X to be the weight. I wanted Y to be Q-sec, and again, you can see this in the PowerPoint. I want the color to be AM, and in fact, I'm going to use the factor of AM. And I would like the size to be the factor cylinder. Don't forget to add the geom point or whatever geom you are choosing to use at the end. And now I have, you notice here, based on the size, I can see bigger cars. There's a 6-cylinder in the middle. Size is nice when you have a very large range of numbers. Actually, you know what? Factors aren't really needed for size. In fact, I'd actually encourage you that if you're going to use size, don't use factor, but for color, I would generally use the factor. It's still tough to see. Notice why I did that is that the 4 really shows you how small that 4 is. One other extra benefit here is that we can always build these from the ground up. So for example, let's just say we started here with this ggplot without the geom. So I'm going to go ahead and save that to G. Now remember, if I say, okay, show me G, after I've saved it, I'll run both of these at once. Saved the G and plotted it, and there's nothing there. But I might say, you know, can you go ahead and put the geom layer on? So I can say G plus a geom layer, geom point. And we'll run that. Again, nothing happened. Why? Well, because I just saved it. I didn't actually view it. When I view it, I see the plot that we had before. And I might say, boy, I'd like to see some other things, like, can you add a smooth line to it? Geom smooth. Let's see what that does. Ooh, it puts some kind of weird squiggly lines on there. But that's actually a spline low S curve that's being fit to the data for each group. I could say, can you do a smooth with a straight line? Method equals LM. We'll talk more about this much later in the course. And you can see, it fits straight lines for 4 cylinders, 6 cylinders, and 8-cylinder cars. We can play with this all day and figure out how to use it. Notice here there are many different geoms. In fact, I'm going to slide this PowerPoint slide in. We can see all the different geoms here. Geom point, geom line, smooth, box plot, dot plots. We can do tons of stuff. Geom histogram. We might see that for a one-dimensional data set. In fact, we'll probably give that a shot here. Many of these have specialty arguments that you might want to use. And geoms also have specialty arguments. You would probably want to check the help for every specific geom. Now you might say, well, I want to look at bar charts. Well, with bar charts, that's another geom. But a bar chart doesn't need an X and a Y, just like a histogram doesn't need an X and a Y. So you really only need an X in there. Now we'll play around when we get to class. We'll talk about playing more with how do we get different fills, how do we get different positions, and what it means. I have all kinds of different options set in here. But we'll talk, like I said, we'll do more of that when we get to class. But I would encourage you to, again, play with it. Histograms, geom histogram, what options exist there? Well, I can specify different bins. I can specify different transparencies if I want to overlay it. All kinds of functions are available. Let's slide this out one more time, and let's say, all right, this ggplot, what can it do for a histogram? Well, let's say I want to make a histogram of the weights. Well, what's my data? My data is the empty cars. My aesthetic, I'm only going to worry about the X aesthetic as weight. And I'm simply going to add geom histogram. We'll run it. There is my histogram. Not especially good. It actually gives me a little warning down here that says the bins that you're using of 30 bins, which is default, is not very good. Perhaps I can set an argument here. So let's try and say bins equal 10. That's a little better. It kind of binned it into 10 equally sized bins, like the breaks function. But gives me a little different view. And it doesn't have as much of a warning there. The 30 is pretty standard as we look through it there. What about bar charts? So let's do that bar chart of cylinders that we might like to see. So we could do ggplot data equals empty cars, AES x equals cylinder. And let's just look at a geom bar. And when you look at geom bar, we get, that looks pretty much the same. Why do we care? What is the benefit? Well, let's throw in some of these options from the geom bar. For example, let's go ahead and say, you know what, I'd like to fill this. Fill. So let's go ahead and add a fill option. One thing you'll notice is that color is for the outline. Fill is for the inside. I want to fill this with AM. And then you know what, I'll say factor AM just to be clear. So basically I can see which ones are automatic and which ones are manual inside each group. And now I see something a little bit more beneficial to me. I can see how these are stacked bar charts. Might say, yeah, I don't like it stacked. Is there any way you can put them like side by side? I think Excel could do that for me. Well, of course there's an option to put it side by side. We could say that the position, and I believe this goes into the geom, position equals dodge. And lo and behold, now I have a side-by-side bar chart that I can see that clearly there's a decreasing relationship in the manual vehicles. As the cylinders get higher, I get fewer and fewer manual. And as the cylinders get higher, I get more and more automatic. Once again, you learn by doing. I have some more slides that I will encourage you to take a look at if you'd like a little bit later on when it comes to statistics. I am probably not going to have the time or need to really focus on it. I guess I can do one quick observation, one quick idea. I'll do some in class, but I won't focus on it too much. I will also discuss briefly a faceted plot. Let's go ahead and look at the iris data set. The iris data set is a very common data set used in statistics. It was actually done by R.A. Fisher. I'm going to look at the head of the iris data set. It was used as a classification data set. He was trying to predict what the species of iris was based on the sepal length, sepal width, petal width. So it's a very seminal research or data set on classification. We'd like to be able to plot it and see if we can color code it based on the species. So the iris data set is one that we use quite a bit in classification. I would like to visualize the iris data set, and before I actually type it out, I'd ask you to do it on your own. I'd like to see a color-coded graph that has the sepal length, we'll say we'll put sepal width on the x-axis, sepal length on the y-axis, and I want you to put the color based on the species. I would like to see a scatter plot of that. I'd like to see what that would look like. So hopefully you've taken a few minutes to work on that on your own. So let's go ahead and give it a shot. So I'm going to say ggplot, use the iris data set. My aesthetics, I said on the x-axis, I would like to see the sepal width on the x. And on the y, I'd like to see the sepal length. Color would be the species. And I'm going to do this with points. I plot it. All right, not too bad. One thing that I can notice out here, it looks like that the setosa, based on the sepals, is sticking out. Looks like the versicolor and the virginicas are kind of overlapping here. Little difficult to see, but the petals will help us distinguish if we want it. But the nice thing here is I've been able to visualize this area here, what makes setosa different. Now, someone else might say, well, why do you have all the points on top? Can I make a separate plot for all three of them that are all kind of next to each other? That's faceting. So how do I add a facet layer? Well, I add it just like I've always done. I'm going to do the iris data set. I'm going to get rid of the color coding for now. So we'll do x equals, this time we'll do petal. Petal length, y equals petal width. And I still want points, geom point. But now I need to say, you know what, I really wanted to see this faceted, a different picture for every single species. So to do that, I'm going to use the facet grid function. And I'll say I want the three graphs to be in the same row. So that would mean that there is no row variable, and to determine the column, I'm going to use species. Once again, by putting a dot there, I'm saying put them all next to each other, no row, and there we have it. They're all on the nice same set of axes, which is huge, a huge improvement over the base plotting system. All of these are on the same plotting axes. The setosa, once again, sticks out a lot, much lower. You notice the versicolor is in the middle, and the virginica is at the larger end with regard to petal length and width. Huge advantage. Very easy to see this, very easy to tell. I will ask you to try on your own what happens if you switch this around, perhaps put species dot, and you'll notice this will just make it vertical. Similar idea, but they're put on a vertical axis. I can put it as 2 by 2. I can put it as species separate one way and some other variable separates the second way. I don't need to convert to factors. It's very, very useful. Two other things I want to add. One is we talked about prettifying our graph. So let me go back to this this one right here, this iris data set. And it looks pretty good. One of the real benefits of ggplot2 is that it puts a really nice legend for me. I don't need to specify it. But I might like to clean up these titles. I might like to put a title on my graph. I didn't have that here. So how do I add titles? Well, that's part of the theme layer. So if I want to add a theme or a label, there's a function called labs for label. And you can say, well, I want the title to be, this is fun with irises. And I'll put a comma. I'm going to hit enter just to make it so we can actually read what's going on here, because I know we're going off the chart. Let's go ahead and bring the labs onto a second table here. So my title is fun with irises. My X label, I don't need to do X lab, is just, we'll say, we'll put fun with iris sepals. So then the X would just be the width, and Y would be the length. Notice it has to be in quotes. I could change my limits if I so choose. I could change my legend label if I'd like. All kinds of different options to make my graph a little bit more presentation worthy. This has been an incredibly quick dive into ggplot2. It might have felt like a long time, but I know I am flying through this stuff. Once again, I cannot emphasize enough how important it is to learn by doing. I will give you examples, give you practice. Please take the time to work through those practice examples and you'll improve as we get through time. Final function is ggplot, which is very useful for quick and dirty plots in the ggplot framework. And what I'm going to do here is basically, it's a quick line that says, say I want that miles per gallon versus weight graph. So I could say I want weight on the X, I want miles per gallon on the Y, and the data is MT cars, and I'm just going to run it. And lo and behold, what does it pop out? It pops out exactly what I would have gotten from that whole long ggplot thing. Well, the thing is that ggplot kind of assumes this is probably the geom you want. This is probably how you want it. So I'm going to go ahead and plot it. What if I said ggplot weight from the data MT cars? It assumes, oh, you must have meant histogram. I can go ahead and add an option, an argument here that says, you know what, I want bins equal 30 because it probably knows I want a histogram. It'll figure it out. But if I wanted bins equal a better number, let's say 10, I can do that. I'd say, well, that was way easier. Why didn't you just start with that? If I want presentation quality graphics, I want the customization, and honestly, I do most things with the ggplot anyway. It's not that much harder to do, but if you're looking for a shortcut, the ggplot is an option. Take the time to go through this practice. Consume it. You'll get better every day. It will take time, but it will be worth it at the end. Visualization is one of those things that over time gets more and more useful. I find how much more I use it every single day. So take that time, enjoy the rest of your week, and we'll see you on Saturday.